This recording is for Advanced Algebra, Lesson 1-1, the language of algebra. Let's start off by looking at 3 vocabulary words. Variable tends to be a topic that most kids are pretty comfortable with. A variable is simply a symbol that you can use to replace any number or other objects. So I'm not going to focus very much on that word. Let's go on to expressions. An expression can be a number, a variable, or a combination of the two. So let's go ahead and put some examples down on our paper as it relates to expressions. If an expression can be a number, let's write down some random numbers. An expression can also be a variable. So let's write down a few random variables. And then you could also put those things together with some kind of an operation. Operations in math class are things like adding, subtracting, multiplying, and dividing. So when you put some of these together, you'd get expressions like 11 plus x or 11x. You could also put letters with other letters. So xy, xy squared, and so on. Once you take some of those expressions and put them together with a verb, or in math class we would call a verb an equation or an inequality, then you can create a sentence. Let's review the symbols for inequality. The less than symbol points to the left. The greater than symbol points to the right. Less than or equal to has a bar under it. Greater than or equal to has a bar under it as well. Not equal to is the equal sign with a slash through it. And approximately equal to, those 6 are all considered inequalities. So let's put some of those expressions together with an equal sign to create some equations. If you put some of those expressions together with an inequality, then you'll be creating an inequality. So together, equations and inequalities are considered sentences. You can see from the picture here the hierarchy between all these different words. Expressions are the overarching idea. Sentences are created from expressions. There are 2 types of sentences, equations and inequalities. And then there's one more word we haven't covered yet, and that is formula. If you have room in this circle inside the equation circle, you can write the word formula. And a formula is a special kind of equation. A formula has one letter isolated all by itself on one side of the equation. Continuing on with some further examples, if you were to look at 4x equals 12, you should be able to come up with some names that would classify that. Because it has an equal sign, automatically, most people would call that an equation. Keep in mind, however, that all equations are automatically sentences as well. So we could call this or refer to this as a sentence, also as an equation, or both. The second one down has an inequality symbol, so automatically we would call it an inequality. Inequalities are also automatically sentences. The last one has an equal sign, so we would call it an equation. Since the letter V is isolated and all by itself, we can call it a formula. Keep in mind that all equations are also sentences. So as you look at those 3 examples as a whole, they're all sentences. Some of them are equations, some of them are inequalities, and one of them is also a formula. One of the topics that is assumed students know in the book is the idea of the commutative property. The commutative property is actually 2 properties, one for addition and one for multiplication. Basically, what the commutative property allows students to do is either add or multiply in any order. So it allows you to rearrange numbers when you're adding or multiplying. Quickly, an example of that would be 3 plus 4 is the same as 4 plus 3. In algebraic form, you'd say a plus b is the same as b plus a. In terms of multiplication, you could do the same thing. You can multiply in any order. So if you did 3 times 4, that's the same as 4 times 3. Algebraically, you'd say AB is the same as BA. Keep in mind that this works for more than two numbers. So if you had ABC, know that you could rearrange those and also come up with the same answer. Another topic in this lesson is the order of operations. There's lots of operations in math class, and we need to make sure that we prioritize them so that we all get the same answer. Most students have learned the Please Excuse My Dear Aunt Sally acronym as a way to help them remember the order of the operations. The P in the please stands for parentheses. Anytime you see parentheses, those need to be handled first in a problem. I'd like to also point out what the book says on page 8 about the rules for the order of operations, and that is that parentheses can include grouping symbols. Both the fraction bar and the radical symbol are considered grouping symbols and need to be considered when it relates to parentheses. The E of the order of operations in the excuse part of the acronym stands for exponents. The next two words are my and dear, standing for M multiplication and D division. Those carry equal weight and equal priority. If you're not sure which one to perform first, always work left to right. The same is true for the last two letters, A and S. A stands for addition, S stands for subtraction, and again, those carry equal priority as each other. So let's go ahead and practice the order of operations with a few examples. The first example has x over x plus y. So what I see there is a fraction bar and an addition symbol. According to the order of operations, division takes priority over the addition symbol. However, the fraction bar works like a grouping symbol. So we need to fill in those extra grouping symbols as parentheses. So now that the parentheses are indicated, we should be adding first and then doing division as our last step. So on this question, we would add, then divide. So if we plug in the numbers that they gave us, we'd have 8 on the top and 8 plus 2 on the bottom, or 10. Always reduce fractions to lowest terms, so here we would get 4/5 as our final answer. Moving on to example 2. This one also has a fraction bar and addition. Because the fraction bar doesn't have anything else besides the x and the y, there are no grouping symbols required. So in this case, we would do the division first and then the addition second. So on this one, we will say divide, then add. So if we have 8 over 2, we'd get 4 plus 2 is going to be 6. Our last example here is a little bit more complex. It looks very similar to the quadratic formula. It's just missing the minus sign under the plus. One of the things you should do when you're asked to simplify is substitute the numbers in. And then I would also encourage you to fill in any grouping symbol parentheses as necessary. Right away I see that I have a fraction bar, so I'm going to put those parentheses in for the top and for the bottom. The radical symbol, or the square root sign, also behaves like a grouping symbol, so I'm going to put parentheses around everything underneath the bar. Now that I see my grouping symbols have parentheses included, that shows me that the most interior grouping symbols need to be the priority first. Within these interior parentheses, the priority goes to the exponents next. So I'm going to take b and square it. B is the number -1, and when I do -1 squared, I get +1. I'm going to leave the subtraction there for a moment and go on to my multiplication. The multiplication here is not the distributive property, it's simply 4 times A times C. Not 4 times A and then 4 times C, just 4 times A and then the answer times C. 4 times 3 is 12, 12 times -4 is -48. And then I'm going to fill in or substitute the rest of the numbers. The opposite of B here is going to be a +1. And on the bottom, I can do 2 times A to finish off that grouping symbol. So 2 times A is going to be a 6. So on the bottom here, I'm going to change the subtraction to addition. And when I do that, I would add the opposite of the numbers that are given. So I get 1 plus 1 plus, oh, and I forgot to do the square root. Let me go back. I forgot my square root symbol, so let's put that back in. So now I need to do my addition, add the opposite. So I'm going to get 1 plus 48, which is 49. And I still need to do the square root of that. Technically, there are still grouping symbols on the top here that I haven't handled yet. So my next step would be to go ahead and do the addition here. So the square root of 49 is 7, plus 1 is 8. And then I still have the 6 on the bottom. Reducing to lowest terms, I get 4/3. Just want to help out students here. If you want to write that answer as a mixed number, you are allowed to do that. So that would be 1 1/3. If you write it as a decimal, just make extra sure that it is accurate. When you write 1 1/3 or 4/3 as a decimal, it should be 1.3 repeating. You would get points off if you wrote 1.33 repeating. So a lot of times I have kids write that answer and then cross it out. Our last example is simply to assist students with one of the examples in the book. It has to do with kilowatt hours, which tends to be a little bit of a trickier subject for some students. In particular, part A. A kilowatt hour is 1 kilowatt of power used for 1 hour. They give us a bunch of information. 60-watt bulb is turned on for 33 hours at a cost of 9.53 cents per kilowatt hour. So we're going to lay out all the different amounts and we're going to do a conversion at the end. So a 60-watt bulb is turned on for 33 hours. So we would simply multiply those together to find out how many kilowatt hours that would be. We do have a problem right away because this is not in kilowatts, but we'll deal with that later. We also need to multiply by the cost, which is 9.53 cents. Be careful here, if you converted that to dollars, it would be 0.0953. But that does say cents here, so if we're consistent, we'll just leave it with that symbol. The label on the cents here has to have a number on the bottom. It says per, so that means the cents is on the top and kilowatt hours is on the bottom. So we say kilowatt dash hours. So whenever you see per, know that there's 2 labels, one on the top and one on the bottom. As we look at this, we've got a fraction here, but these other 2 are not fractions, so the best way to handle it is to turn those into fractions by putting a 1 underneath. Now let's pay attention to the labels. Right away I see that I've got hours on the top here and hours on the bottom there, so those are going to cancel out. Hours divided by hours makes a 1. 1 multiplied by all of these doesn't change the result. The next problem I have is that the watts and the kilowatts don't match. Students need to remember that 1,000 watts equals 1 kilowatt. So we can turn that into a fraction. We turn it into the fraction that helps us here. We need the kilowatts on top and the watts on the bottom. So if we do it that way, the watts will cancel because there's 1 on the top, 1 on the bottom, and the kilowatts on top cancels out the kilowatts on the bottom. Then students would just go ahead and multiply across to get the final answer. For part B, you would simply label everything that you've done with a letter. Power times time times cost equals A.